In this video, we're going to write complex numbers in polar form. It says express the complex number z equal 5 root 2 plus 5 root 2I in polar form r cosine theta plus I sine theta. So the first thing we need to find is what r is. And we know r, the radius, is equal to the absolute value of z. And we know that that is actually equal to, the absolute value of z is equal to a previous assignment, or objective, root a squared plus b squared. So if we go through and we say that r is equal to a squared, which would be 5 root 2 squared plus 5 root 2 squared, square root of this, we end up with r is equal to, when I square 5 root 2, I get 25. Root 2 squared is times 2, plus 25 times 2 here. So I end up with r is equal to root of 100. So r is equal to 10. Now I need to take this and use this in this formula. So I'm going to say that 10 times cosine theta plus I sine theta. Now what I need to find next is theta. So how am I going to find theta? Well, I know that if I draw this triangle here, and remember our x-axis, so I'm just going to kind of use axes here. Remember our x-axis is the real number system, and this is the imaginary number system. I have 5 root 2 here for the real number system, the first 5 root 2. And then I have 5 root 2 here for the imaginary part. I can find that angle by doing tangent. So I can say tangent of theta is equal to 5 root 2 over 5 root 2. So tangent theta is equal to 1, and that occurs when theta is equal to pi over 4. So now I can take pi over 4, and I can plug that in and say that that is actually equal to 10 cosine pi over 4 plus I sine of pi over 4. And now I've taken that complex number and I've written it into polar form.